So hello and welcome back to the new video of the Java tutorial series. So till now we have looked at the deletion operation. We have begun with the deletion operation and we have seen delete at beginning. Okay, so in this video we will be looking at the delete at end. So now what I am talking is we have to delete the node which is at the end of the linked list. All right. So before going to the code part, as we discussed through Paint, let's discuss. So to perform the delete operation at the end of the linked list, what do you guys think? What will be required? Okay, so first thing we will require the access to the previous node, right? Like that is the second last node of the list. So as I'm assuming this linked list. Okay, so this is our linked list, and one thing, you don't get confused. Some YouTubers have told you to implement this single linked list without taking the tail. They are just taking the head of the linked list. They are not assigning the tails value and they are not maintaining the track of the tail. So and I have taught you by taking the tail. So I think this is the good idea to take tail in the linked list, so that you have at least the track of the two nodes in the list, that is the first node and the last node, so that those are required whenever you perform some complex operation on your linked list. We'll see what I mean by the complex operation. All right, so this is the list, one two three nodes are there, and this is the data part of the list, and this is the next part of the list, and this is the linked list. Okay, so we are trying to delete the last node of the list. So if you want to delete this node, we'll require the track of this node. That is the previous node to the last node. So first thing, we need the track to this node. Somehow we have to get to this loop, get to this node, sorry, not loop. And after that we can perform some basic stuff, that is we'll reassign the value of the tail to this, so that our new tail will point to the new last node of the list, and we will just simply assign this part next value to the null, so that our new list should look like this: 1 2, and second node is pointing to the null, and we don't have any more access to these nodes. So this node is getting discarded from our list, and this is our new updated list after performing the deletion operation at the end of the list. Okay, so let me get rid of this. Okay, so now we can go into our code IDE, and right beneath of this deletion at the first node of the linked list, I will make one comment and I will write it as delete at the end of the list. All right, so now since this we are making this method, and this method will be a public one and static also, and now we are deleting the node from the list. So our list is getting modified. All right, so we are getting a new list. So for that, this method will also release, or means pass, or the returns one head of that list, new list. Okay, so that we can use that head later on to print that list. Okay, and we'll write delete at end, and this method will also require the head of the list, that is access to the list. Oops, sorry, wait guys, wait, delete at end, and this will require node as head. Okay, so inside this, so as we have discussed in our previous video, we are checking this if condition, that is a corner case. So what do you think, here also we have to check one corner case, right? We have to check one corner case. So what it will be, if our head is equals to null, that means if the head that we are passing to this method, that head is null, or head dot next is equals to null. Guys, what do you think this condition will get? This is the OR operator. So I hope you know what is the OR operator. Those who don't know, I will tell you. OR operator will evaluated this one expression and this one expression, and whether any OR operator, what it does simply, if any one of the condition is getting true, this if condition will be executed. All right, so if the head is equals to null, or the head dot next is equals to null, if any one of this condition is evaluated as true, this if condition will be get perform, and we will just simply return the head. Okay, and what we are doing over here is, if the head is equals to null, means this is the condition where there is no element inside the list. All right, and this when head dot next is equals to null, that means the head dot next, that is this location is pointing to the null. So what it depicts is, there is only one node inside the list, and if there is one node inside the list, so technically we can't remove the end of the list and end node of the list. Okay, so because there is only one node present inside the list, so we can't perform this operation. In that case, we will simply return the head of the list. That means this is the condition. All right, and after checking that corner case, if that corner case doesn't evaluate it, then we'll simply create one node. I will name it as previous. So because we have discussed in our logic part, we need to keep the track of the previous node of the linked list that we are going to delete at the end. Okay, so now we have declared one variable of previous of type node. Okay, so we have to take that. Currently this is previous is pointing over here, and now if we want to delete this element, we have to get this previous somehow to this location, so that what previous will do, it will hold or keep the track of the node which is just behind the tail, that is the second last element of the list. Okay, so we are performing this while loop so that we can keep the track of that previous until previous dot next is not equals to tail. And I hope what is tail, the tail is the last node of the list. So whenever this until we reaches to the tail, which is the previous node of the tail, we are performing this, and each time we will be doing previous is equals to previous dot next. That means we are incrementing the previous value to the previous dot next. And once we have reached to the previous node, we will just simply write tail is equals to previous, and now we will write tail dot next is equal to null. All right, and after that we will just simply return the head of the list. So here you can see we are declaring one previous variable and assigning to the value of head. We are looping one while loop, and we are taking that previous variable to the second end of the, which is the second element from the last of the list. And after that we will just simply assign the tail value to the previous. That means we are shifting our tail to over here, and we will just write tail dot next is equal to null. That means this will point to the null, this will point to the null, and this link will got broke, and we have no more track of this node which is previously at the end of the list, and our list will be like this: 1 2 and null. All right, this is the logic behind deletion at the end. Okay, I hope you got that idea. And now we will go inside the main method, and over here we will just call those methods that we have declared above, and we'll delete and end. We'll pass that head, And after that, since we are getting the new head from that list, so we have to capture that new head, or new head equals to, and we'll see new head this. Okay, let me run this. Okay, so we are entering the nodes like 1 2 3 4 5, and after that I will write -1. So here you can see before performing the deletion operation, the linked list would look like this: 1 2 3 4 5, and after performing the list delete at end operation, we are printing again the list, and this time we are printing 1 2 3 4, and we are deleting the element which is at the end of the list. Okay, so this is how the deletion at end works. I hope you got this idea how it is works. So if you not get any idea, go back and watch this video again. So in our upcoming videos, we will see how to delete a node inside the single linked list which is at the user specified location. Alright, so thank you for watching this video.